Okay, so update, this Monday will be your exam, so exam 3. It will be upstairs again in the Engman lab. For those that are going to take it online, make sure to email me to let me know so that I can send you a unique link. Otherwise, plan to take it just like the other exams up in the Engman lab during this period. So Monday, usually they've been on Wednesdays, so note the difference in day, so Monday, and then reading day will be Wednesday, so that will be our last class, will be Monday. If you do well on that exam and you've done well on all the exams, then you are done for the semester. If you want to opt to take one of the finals or all 3 of the finals, you may do that. It will be Monday, April 29th will be the final exam date. And so it will follow whatever the normal exam time is on the final exam periods. Yes?
How soon will the grades for exam 3?
Hopefully very quickly so that you can know if you want to take it the next week. So I'll be asking her to finish them up by Thursday if she can. So you should know by later that week. Any other, yes?
Is the final exam also in the lab?
Yes, so the Engman lab will be where we will have the final exam unless you contact me, and then you'll be sent that unique link to take it, but it will be during the same time. There is an exception made to online students that are in the online section if you have a conflict in time due to your other final exam that date. So yes.
Can we take like multiple exams?
Yep, and I will take the higher of the 2, so if you do opt to take the exam and you do worse than you've done, you'll still get that grade of the higher exam between the 2. I usually get always that question, so yes, it will be the higher of the 2 exams that you take will be what will be kept. All right, any other questions? It will be similar format to all of the other ones, so it won't be any different. So you have to work very quickly if you plan to do all 3 in the 2-hour period. So that's the hard thing, is you will still only have that 2-hour period. I usually will let you go a little bit longer, but 2 to 2.5 hours to take all 3 exams. So most people don't take all 3 exams, but you're welcome to if you want to. All right, any other questions about time frame of what's left? So group work will be due on Monday, even though it's the same day. So I didn't want to have it due. So try and get it done before the weekend so that you can have that as a preparation. But just because I don't like to have things due over a weekend, I did put that date of due date to be Monday, but don't procrastinate. Use it to help you to study for the exam. All right, so same expectation for the group work or individual work. That is to help you prepare for that exam. This exam will have complex power, so understanding how to find that complex power. It will be the calculations of them, identifying what is apparent power, which is going to be in the polar form, that's the magnitude, identifying the average power absorbed, reactive power, and that's the rectangular form for both of those. And then understanding how to find the power factor. Again, that power factor is a percentage of how much is average power out of the whole total. So it's a fraction under 1. 1 means that it's fully real, and then any other percentage of that is how much is real of that. And then from the leading or lagging, that's in the polar form, the theta that you find as far as that angle, and then you use, if it's plus, then you use, it's lagging, it's inductive. If it's negative, then it's leading, and it's more capacitive. So that helps to understand how that is affecting the current versus the voltage in your system. All right, so that's what you need to know for complex power. Maximum power transfer, you need to know how to identify the Z load. So if I was to put on a load, what does that load value need to be? And also how to find the power that would give you. And so that requires you to find VTH and RTH of a circuit. And then the third type of problem will be a filter. I'm not going to have you graph during the exam. That was in the homework. You had to graph that. But that's why you did it in homework, so you know how to graph it. but be able to identify from a graph what type of filter it is, understanding what the Q factor is, identifying the key points, the resonant frequency, and then the cutoff frequency locations. So being able to see that from a graph. And then Fourier analysis is to use from a circuit, apply the Fourier transfer or transform, going to that S domain, and then analyze the circuit, be able to manipulate that equation to then again be able to map it or match it up to the table, or be able to take the transform using that direct delta function properties and being able to get it back to time domain. Okay, so that is the concepts that need to be done. So last time, or 2 times ago, we went through finding the power values. So that was this example. And then in this one, this was for the max power transfer. So you find the maximum power when ZL is equal to ZTH complex conjugate. So you just find that in rectangular form is usually the easiest way to find that. And then take a negative for the J. And that will give you the ZL. And then solve the circuit with removing the load between A and B. That will be your VTH. And then find that in polar form and take the magnitude portion of it. So in this case, we found the ZL, and then we found VTH, and then the magnitude portion of 0.3123, and then use that, and you use the real portion of the ZL to find that power that's dissipated. All right, and then this was another problem that I did online. And this was the transfer function. So I won't make you solve the circuit for the transfer function either, but do understand how to find that. And then this was the code to be able to use MATLAB. So in MATLAB, it's nice because you can click on the graph and then drag it around and find the actual locations. So that's why I like to use MATLAB to find those values.
So you won't make us find the transfer function, given the circuit?
Correct. I'll give you a graph, something like that instead. And I'll try to mark it better so you can read those points clearer if I ask you for the specific points. But hopefully, from this, hopefully you can see that it is directly like omega naught would be that 10 to the 6th. Okay. Okay, so let's do the transform is what we haven't done yet. So we're going to work on this. And this is going to be a little interesting. I forgot my pencil, so you get to see me, right? So I don't know how nice this is going to be, so I might be copying and pasting more.
Don't practice your finger painting.
I know, it's kind of a little different. Okay, so you have VS1 and VS2. Let me find out what those values are. And you want to find IL of T. Give me a second to go back and find what those values will be. So you'll want to solve the circuit for IL of T going through the inductor. I didn't solve this fully so just solve this in terms of VS1 and VS2. So use them just as a variable and keep them in there as a variable. Okay. So, anybody want to share how they solved this? Go for it, Adam.
Alright, and I'm gonna have the numbers completely wrong because I dropped the Miller prefix, but,
Oh.
I started by looking at that and I did a, Thevenin equivalent.
Okay.
Where I could recognize, that if I remove the, inductor, then I can calculate the total impedance without that, just in series, and find the voltage that would be at that node without the inductor there.
So you combine,
Yeah, I can combine those with the other
Uh-huh.
resistor. I just remove the inductor and treat that whole thing as a circuit in parallel to the inductor. The whole thing without the inductor.
so you could find a Thevenin, but it doesn't really help you of just the right side, but the left side combining it is different. So when you,
I took both sides into consideration when I found the
Okay.
Thevenin.
so you put your A and B, so your A was located here and your B was here?
Yeah,
And then you removed the inductor. Okay, so you found the Thevenin for A and B and ended up with, oh, love the, sorry. I guess these would be a ZTH and a VTH.
that way I didn't have any systems I needed to solve with the complex numbers. I just had some values and just go through multiplying things and simplifying.
Okay. And then 10/377 S. Okay. So you created that and found ZTH was A and B. All right. That is one way to solve that. And then I'll just write ZTH you found to be 50 plus 1 over, I'll write it the other way, 377 milli over 20.
Shouldn't it be 377 kilo over 20?
Yes. Yeah, that's not good. S, okay. And then VTH.
I found that it was VS1, well, so I started by finding, the current, but then I found that an equivalent more useful than Norton, so I changed it. So to find the current, I divided by that Thevenin resistance there, and then I needed to multiply by, and then I multiplied that by my 20 ohms and subtracted from VS1.
Let's see. So this would be a minus. Yeah. VS1. VS1. And then I have it going that direction. So then it would be VS1 minus that. Yep. Okay. So that was what you got.
And then from there, I can just, add my, inductor into the mix with my Thevenin resistance and divide my Thevenin voltage by it, and I've got the answer.
Okay. So that is one way to do it. I, of course, like node voltage. So node voltage would have been IL is Vx over the 10/377S. And then you would do Vx minus Vs1 over 20. And then Vx over 377 over 10S. And then Vx minus Vs2 over 30 plus 1 over the 20 milli S 377. And then equals 0. And then MATLAB has a nice tool called symbolic, so you can do sims, and then you can call whatever variables you want as symbolic. So I used MATLAB called sims, VS1, VS2, Vx, and S are all symbolic values, and then I plugged in the equation themselves, and then you can use a solve. And that will solve for, in this case, it solved for Vx first. And then I did the solve for the Ix, or IL. And so that ended up giving me this answer. So this leads to like, then how do you transform this back? This one was a little too complicated to transform back. So we're going to do simpler ones to transform back. So what is the Fourier transform value at a specific omega value for an input spike modeled as an impulse A delta t? So looking at the transform for Fourier, it transforms from delta t to a 1 in f of omega. So at omega equals 10, I'll do 10 here. If omega equals 10 radians per second, what would your Fourier transform value be? Yes.
It would be A because it's a constant and we transform the delta function.
Correct. So that would be your answer there. It's just A. It doesn't matter what omega is. Always A. Does that make sense? Yes, no? Okay. All right. A circuit is solved using Fourier transform method, which results in the following function, which is this one. Calculate IC of t at a t of 10 seconds again. So take a moment and try to solve this transform by converting it back into the time domain. Hint, use the Dirac delta properties to do the first portion of that transform. Uh-huh. Thanks. Okay, so what happens to the first portion of this when you transform it back? Anyone?
Using the direct, whatever that is called, omega becomes 0 for that first portion, which basically wipes it out entirely.
Correct. So correct. This goes to 0. So when you integrate it, remember you have the delta function times any other function. You evaluate it at omega equals 0. So here, this omega equals 0 in the top, we'll set that equal to 0 for that portion. So that becomes a times 0. And then what happens to the 2 over j omega?
That becomes the sine function. So the sine of the number. So -1 if it's less than 0, +1 if it's greater than 0, 0 as 0.
Correct. So that's the graph of the sine function. So it's kind of like u of t, except for on the negative side, it's -1 first. So it's going to just multiply it by whatever b is. So at time equals 10 seconds, what will IC of 10 be? I heard somebody say it. Say it a little louder. It'll be what? It'll be what? 0? B? I heard 1. So remember, it's going to be b times 1. So it will be b. So the graph of this, so b times sine of t is just -b and then b. So that's what that graph looks like. And so at time equals 10, it will just be a value of b. Does that make sense? Okay. So let's do a few more. What if IC omega was 4 plus 2 j omega? What would that look like? What happens to the 4? If you have a 4 in the omega domain, you translate it back into the time domain, what is it? Yeah, it's the delta function. So you take 4 times delta. Oh, my finger writing's getting better. And then 2j omega is the sine of t. And in this case, it's not multiplied by anything, so it will be an additional 1 added on. So at 10 seconds, what will this look like?
It's just the sine function, so it's just 1.
Correct. Oh, I already have it written down there. So it will just be 1 because the delta function only is valid at 0. So at 0, what will your value be?
It depends on how you interpret the delta function.
So it's hard because
It spikes.
it's going to be spiking. So you're going to have a spike up at 0 to 4, and then it will go to 1. So it will go up to 4 and kind of down, or it could even go up to kind of 5 and then down to 1. So kind of spike up and then go down. But it will also be like +1, and then you'll have the -1 on the negative side. So it's kind of hard to say what would be the value at 0. So it's kind of undefined at 0 because it's unclear what it would be exactly. What about at 2 seconds? IC of 2 will be what? Anyone?
1.
Thank you. 1. Okay. All right. If IC omega is equal to 6 plus 3 pi delta W plus 3 over j omega, What's that one gonna be? So you do them each piece, so 6 becomes what? 6 delta t. And then we want to see, is there a match for a 3 pi delta omega plus 3 over j omega? Does that match to anything? Just u of t. But there's something in front, right? Yep. So 3 u of t. So at t equals 0, what will this one be? So the delta t will give you 6, right? What does the 3 u of t give you? U of t gives you a 1, right? But then it's multiplied by 3. So you'll have plus 3, so you actually get the value of 9. So you just add those two together. So remember, u of t is because it gives you the 1 value at 0. So you add that in. What about at 10? What would that be? What does the delta function give you when your t is at 10? 0, correct? And then what?
3.
And 3, so this one will give you 3. That makes sense? Okay. All right, so let's do another one. If I see omega, love the finger, 7 plus 5e to minus j 3w. What one will that give you? You guys see these? So the 7 gives you what? Okay, so IC of t will be the delta t. And then 5ej to the minus 3 omega. Yes.
That's going to be 5 times delta of t minus 3.
Uh-huh. Okay, and then at 0, what will the value be?
A spike.
Of what value?
7.
7, correct. So this portion at 0 will be 0. What about at 2 seconds? 0, right? Because the first portion will be 0, and the shifted one will also be 0. What about at 3? Correct. So the first portion will be 0, and then that one will be 5. And then anywhere else it will be 0. Okay? So graph of that looks like a spike of value 7 at 0 and a spike of 5 at 3. So that's what your graph looks like. Oh, that's what your graph looks like. Okay, so for the exam, make sure you understand the delta function, graphing it, flipping it, doing the Fourier with it, understand u of t, understand sine of t, as far as what those functions look like. Okay, and then the normal ones that you've seen, the e, so ej, e raised to the j, which you see a lot. Don't worry about the sync one. And then also understand the cosine. So being able to understand those. Well, 1 over a plus j omega is also a common one. So that goes back to an E form of U of t. All right, questions? Okay, we'll continue. Any requests for specific types of problems for Friday?
Maybe cutoff frequency.
Okay, cutoff frequency. Any others that you want me to?
One question, for like, looking at a filter graph and like determining the Q value, do we just like look at it and kind of like guesstimate based off the shape? We're not supposed to do like actual
Correct.
calculations? Okay.
Yeah. Yeah, it's just mostly the shape. Do you want me to do some of those examples? I'm seeing yes. Okay, so filters.
Maybe just a couple of them.
Yeah.
Okay, so we'll do some filter examples. Okay. So filter examples, we'll go through kind of the spectrum of what you would expect from those. Other requests? Okay. So I will come up with some problems and we will do some more on Friday. All right, see you guys then.
There's no lectures after the exam on Monday, correct?
Correct.
Okay.
Reading day will be Wednesday.
Okay.
So no class. Sorry, just 1 second. Let me just stop this.
Just to for example.
I'm still lost a little
Are you
bit.
coming to lab today?
Sadly,
Okay, good, 'cause you have all
I have
stuff.
the
You
other,
our
I have the
stuff.
other half of the circuit. So I'd love to go home, but I can't.
More specifically, can we go over
Yeah.